How long would you like to be near Explorer 1? Yes, truth be told, the antiquated test has done it once more and again demonstrated that, notwithstanding every one of the difficulties, it is still a solid station in the secretive universe of interstellar space. This was gone before by an event that has nearly become part of NASA's daily schedule. The specialists had lost contact with Explorer because of technical issues. This was not the first time they had been compelled to find clever fixes to re-establish contact with the maturing rocket. Finally, the way to success led through a part that had, all things considered, been old for quite a long time. However, the reinforcement transmitter, which had not been used since 1981, filled in as wanted and allowed the space veteran to telephone home again. When it's cold outside, it's a smart idea to turn on the heating, so self-evident. However, it gets a little trickier when the temperatures in the depths of interstellar space need to be turned up. What's more, on a rocket that has been going through space for nearly 50 years and has repeatedly attracted attention for its technical infirmities, so it happened that what ought to have, yet again, been a normal task led to an unexpected Explorer 1 issue. After NASA specialists had given the space apparatus the order to activate one of its radiators on October 16th, they were confused to find, 2 days later, that the Deep Space Organization could no longer detect Explorer 1's signal. The way that the specialists had to wait 46 hours before realizing this was due to the enormous distance that currently exists between Explorer 1 and our natural home. Specifically, since 1977, the test has been separated from Earth by around 24.7 billion kilometers, and it takes nearly 23 hours for a message to cover that vast distance. The same period of time is thus also required for the response. But what really occurred? Well, Explorer 1 is essentially prepared with a locally available error protection system that responds autonomously to issues. This is the case, for instance, when the shuttle's power supply is overburdened and the error protection system switches off systems that are not in any way essential for the space apparatus to function in order to save energy. Yet, of course, the aforementioned heating command also set off the error protection system. Despite the fact that Explorer 1 actually had enough energy to activate this part, it was temporarily blocked. For a better understanding, it should be briefly mentioned that Explorer 1 regularly communicates with Earth via a so-called X-band radio transmitter, named after its particular frequency. Following the loss of contact, the specialists correctly assumed that the error protection system had reduced the rate at which the corresponding transmitter sent its information back. This isn't business as usual since this mode consumes less energy, but unfortunately, it also changes the X-band signal that the Deep Space Network has to search for. Luckily, NASA engineers were able to detect the signal of hope on October 18th. And, despite the fact that Explorer 1 appeared to be in a stable state, the next issue wasn't long in approaching. How a 40-year-old backup transmitter helped NASA out of a tight spot. The following day, communication with Explorer 1 actually ceased completely. The flight crew thought that the error-prone villain was hiding in the error protection system again. It's possible that the system was triggered once again by mistakenly turning off the X-band transmitter and instead switching to a second radio transmitter, the S-band. However, this had actually been in technical retirement for quite a while. Although the S-band consumes less power than the X-band, Explorer 1 had not used it to trade messages with Earth since 1981. A brief historical note. While Explorer 1 has now even passed the limits of the planetary system, at the time, it had only just explored Saturn and its moons. Unexpectedly, 1981 was also the year in which U.S. President Ronald Reagan and Pope John Paul II were both seriously harmed in assassinations, and in which the current King Charles married a certain woman. Back to the present. We can see why the S-band had been obsolete for a considerable time. Regardless of all the energy-saving benefits, it uses a different frequency from the X-band transmitter, and consequently it has a much weaker signal. Given the immense distance, the NASA specialists were initially uncertain whether they would even be able to detect the S-band. However, they found it and then needed to decide what steps to take next. Considering the error protection history, simply switching the X-band back on seemed too risky. This should only be done once the cause of the system being triggered has been clearly identified. Previous experience has shown that such an error investigation could take weeks or even months. But does this now mean that contact with Explorer 1 will also be lost during this time? Well, fortunately not. After all, there is still the S-band transmitter. On October 22nd, the specialists sent an order to check whether it was still working properly. And lo and behold, on October 24th, the reassuring answer came back. A stable connection had been restored. So, it turns out that NASA's backup transmitter, which has not been used in over 40 years, is now helping in a time of difficulty to maintain contact with humankind's most distant station. However, notwithstanding all the stirred S-band transmitters, it's also undeniable that the journey to the edge of the solar system has now noticeably negatively impacted the test instruments, and we may slowly but surely have to come to terms with the idea that even the longest-lasting success story in space travel will eventually come to an end. How the life of the Explorer tests is being extended, yet the hour of goodbye has not yet come, and that is the good news. However, it's also a fact that the people behind the Explorer mission sometimes need to find smart fixes to extend the lifespan of their sister tests, which are identical in development with standard certainty. Yet, nobody could have speculated in 1977 that it could come to this. When the Explorer test set out into the vastness of space, the anticipated mission length was only 5 years. The fact that the shuttles have now surpassed this expectation by nearly 3 times is mostly because they have since been placed on a strict power diet. To save energy from the aging radio core's batteries, NASA has methodically turned off increasingly more of its instruments. For instance, the use of Explorer 2's plasma sensor has been a relic of times gone by for half a month now in order to supply the remaining instruments with energy for a couple more years. However, this power-saving arrangement is always precarious, as soon as something unexpected happens. For example, if a crucial nozzle fails to work, it could be just the earthly specialists who save the day. Well, the nozzle goes. But what happened? Well, for the Explorer tests to point their receiving antennas toward Earth and telephone home in the best ET way, they need to position them using small positioning engines. These engines, filled by fluid hydrogen, adjust the orientation in a few bursts that last a couple of plant milliseconds. Explorer 1 originally had 3 sets of these mini-engines, but after years in space, stores also accumulated in the fuel lines, and NASA had to change from the first to the second set of nozzles as early as 2018. It finally switched to the third set of nozzles, which was actually designed for course correction. Unfortunately, this set recently came into the spotlight due to supposed clogging, or in other words, blocked lines. Furthermore, the situation is much worse in this case than in the previous ones. While the original width of the course correction nozzles was still 0.25 millimeters, today it is only 0.035 millimeters. To put that in comparison, that's not even a fraction of the diameter of a human hair. Before the parts finally give up the ghost, the specialists decided to switch back to one of the 2 previous, less-worn nozzle sets. But that's not exactly simple or easy. After all, Explorer 1 has barely any energy left, notwithstanding all the power-saving measures, and any extra power consumption could, in the worst-case scenario, mean the failure of a crucial system. And that's precisely the core of the matter. In order for the alternative engine set to be turned on again at all, it needs to be preheated due to its drained energy reserves. However, this is only possible if another system is deactivated to free up power. But which one? Well, that was essentially the question, because in and of themselves, all the systems that are still running are really key. To make matters more complicated, the scientific instruments probably won't turn back on once they have been shut down. So, it was that NASA researchers first withdrew for several months to pore over their computations and tests. At the end of this deliberation stage, it was once again decided that turning off one of Explorer 1's primary heating units posed the least risk. On August 27th, the time had come. NASA completed its risky fly change move and was eventually rewarded for its boldness, because while the primary heating unit was shut down for 60 minutes, the nozzles warmed up during this time, enabling Explorer 1 to point back at Earth. From that point on, well, at least for the present, as mentioned, this set is also anything but brand new. But instead, it already has a history of clogged pipes, and at some point, regardless of how refined the nozzle changes, they will no longer help. Since even if the Explorer 1 antenna is still pointing toward Earth, specialists believe that radio contact will be lost by 2036 at the latest, due to the steadily increasing distance. And our specialists believe that your last contact will occur shortly.